graphing linear inequalities. We're going to start by graphing a line on a coordinate plane just like we've been doing, right? But then we have to shade one side of the coordinate plane. Let me know if you can't read something. So the shaded side, or the shaded points, are the solutions to the inequality. If you did not come at lunch and you wanted extra time today, I will let you stay after school today. You just need to stay here and do it then. That's if you have an accommodation for extended time. Can you see there, Kayla? Okay. So once you guys are done, I'm going to do an example for you. Oh, and we didn't talk about what an inequality is. Do you guys remember what an inequality is, Tosh?
Oh, what's the last question?
Inequality. So an inequality, remember, is less than, greater than, less than or equal to, or greater than or equal to. So what we're talking about here is, looks like a line, looks like the equation of a line, but instead of having an equal sign, it's going to have one of these symbols. So, less than, greater than, less than or equal to, greater than or equal to. Good roll. Alright, so absent, I have Sydney, Aiden, Jeremiah, Omar, and Jalen. Is that right? Okay.
I think Omar is in there.
Alright, well, I have to mark him absent if he's not here. They can excuse his absence if they want to, though I just can't. There's not a way for me to excuse it. Alright, you guys caught up with me? Alright, so I'm gonna graph an inequality and show you what I'm talking about. So don't write anything right now. Put your pencils down and just watch me, and then I'll let you copy it, okay? So for example, if I have y is less than or equal to 3x plus 4. That's an example of an inequality, a linear inequality. It looks like an equation, but it's got an inequality symbol in there. Does that make sense to everyone? this inequality is still in what we would call slope-intercept form, right? The y is isolated, this is still the slope, and this is still the y-intercept. So the first thing we do is we pretend that that's a line, pretend that it's y equals 3x plus 4, and graph it. Okay? So the way we do that, we start with our y-intercepts. We're going to go up 4. You're just watching right now, and then I'll let you copy. And we're going to put a dot. Now we're going to use our slope in rise over run form and plot some more points so we can draw our line. So here, I'm going to go up 3 into the right 1. So up 3 from the y-intercept, remember. 1, 2, 3, into the right 1. I want another point, so I'm going to do the opposite. Remember, 3 over 1 is equal to negative 3 over negative 1, right? So now I'm going to go down 3, 1, 2, 3, and to the left 1. And now I'm going to draw my line. Remember, our line needs to extend all the way through the coordinate plane. So that is the graphing of an equation. But I said this was an inequality. So up here I said we graph a line, but then we have to shade one side of the coordinate plane. So I'm going to shade this side of the coordinate plane. So by shade, you're going to use your pencil. I'm going to use this highlighter. So I'm shading this side of the coordinate plane based on that inequality. That means any point that I shaded over here is a solution to this inequality. So for instance, this point here, 1, 1, that isn't a shaded part of the coordinate plane, right? So the shading means it's a solution. Shaded means solution, S and S, okay? So if I took this coordinate, 1, 1, that is shaded, and I plugged it in here, it should make it a true statement. So let's do that. So remember, this is an x coordinate, this is a y coordinate. So I'm going to replace the y with 1. So 1 is less than or equal to, now I'm going to replace the x with 1, because that's my x value, 3 times 1 plus 4. So this is my check. I'm going to give you time to copy it, guys, if you'll just wait a second. I just want you to watch first, okay? So now 1 is less than or equal to 4 plus 4. So 1 is less than or equal to 8. Is that a true statement? Right. That's true, so that means that is a solution. Now anything that's not shaded, I could pick another point up here. So let's pick a point that's not shaded. So let's go out farther because I'm not an expert grapher. So let's go out here and go 1, 2, 3, 4, and up 1, 2, 3. So let's say this is point 4, 3. It's not shaded. So this is a true statement because this was in the shaded part. Let's look at the part that's, pick a point from the not shaded part. Remember, that's the x and that's the y. I'm going to replace the y with 3 this time. So this is the point I'm replacing. This is non-shaded. Here I replaced it with 1, 1, right? So this is a solution. So I think that this one is not a solution because it's not shaded. But to check it, I replace the y with 3 is less than or equal to it's negative. My B. Negative 4 is less than or equal to 3 times negative 4 plus 4. Does everybody see what I did? Okay, so now 3 is less than or equal to negative 12 plus 4. So 3 should be less than or equal to negative 8. Is 3 less than a negative number? Can a positive number be less than a negative number? No. So that's false, right? And that's good because I thought it wasn't a solution. So now I've checked my shading. I shaded the right side, the correct side. Does that make sense, Sam? That makes sense, Kimani? Alright. Now there's a lot of other stuff going on here, but I'm going to give you 3 minutes to write all that down because I told you just to watch and then write. So now you have 3 minutes to finish writing it all down. Taj, did you already write it? Yes? So you wrote the second part, the second check? I don't feel good. You're going to make me get up and check you? Sorry? Good job. So I'm going to tell you how do you know which side to shade. And there's another thing I didn't tell you, which is sometimes these lines can be dotted lines. So sometimes they're dotted, sometimes they're solid. And I'm going to tell you which times you should use a dotted line. Off my wall, Armani, and off my Harry Potter robe. I don't want any magic to rub off on you. Turn and face front. All the way. Keep going. Off my wall. There you go. All right. I'm waiting for pencils to be put down, then I'll know you're done writing that part.
How did you get 4 for the true statement?
Because I messed up. Thanks, Jacob, for correcting me. Yeah, I added there, didn't I, instead of multiply? So this is so my pen, when I have it, this fine thing also doesn't write, so I gotta make it a little bit bigger. Because this is a +4. Alright, so let me fix that. So, remember, I'm always ask you to write in pencil. Not just for your mistakes, but for mine. Try not to make it too fat or too skinny, but alright, so that's 3, it's fat. Times 1 plus 4. And so this should be 7, not 8. Thanks. Oh, can't get it to go. So let's correct yours. So that's 3 plus 1 is 7. It's still the same. 1 is less than 7, but I did mess that up. I'm having an off day. It is still a true statement, but it's better to be lucky than good sometimes. So, Taj, did you catch my mistake there? Are you fixing it then? Okay, good. Bless you. Alright. So the shaded part is solution, the non-shaded part is not solution. Solutions are values or coordinate ordered pairs that when you plug them in the inequality, it'll make it true, like this one. There's an infinite number of solutions over here. There's an infinite number of points that can be shaded. It can be shaded all the way out here into the hemisphere, right? All the way out into space, right? It's an infinite number of solutions. All right, so here's some things we need to know. When the symbol is less than or equal to or greater than or equal to, we graph a solid line. So here, less than or equal to, I used a solid line. But if it's not or equal to, if it's just less than or greater than, we graph a dotted line. The next thing we need to know is, how do you know which way? Yeah. How do you know which way to shade? So now for the shading, less than or equal to, we shade down, and I'll talk to you about what that means. For greater than or equal to, we shade up. So this was less than or equal to, I graphed a solid line, and then I put my pencil on that line and I pulled down, and this is the side I need to shade. Down is a little bit confusing because it looks like down could be over here too, right? It's below that line. So the way that's easiest to do it is put your pencil on the line and pull down.
The student last name indoors, they're signing out.
Okay, thank you. All right, Kimani, you will just finish watching the video and turn it in tomorrow by 7:30, okay? All right. So now you guys have 8 problems on the front. It says 1 through 10, but if you'll notice, there's not a 7 or 8. So let's do a couple of your problems together. Now, look at 9 and 10. 9 and 10 are not in slope-intercept form, right? So before we graph these lines, we're going to put them in slope-intercept form first, and then graph, just like if we were graphing an equation. All right, so that's what we're going to do next. So let's pick, we're going to start with, let's not start with 10, but we will do one of those. We'll do 9 or 10, and you can do the other one for homework. I'd like to import your assignment there, so give me a second. All right, hold on, it'll be easier to find it this way. Okay, so this is your worksheet. So we're going to start with number 1. So number 1, the first thing we're looking at, is it in slope-intercept form? Yep. The next thing we're looking at is, what kind of line should it be? Should it be a solid or a dotted line? Solid. Remember, if you want to write it on your worksheet, it's not a bad idea. Less than or equal to or greater than or equal to is a solid line. All right, so now we're going to graph. We should know how to graph at this point. We know that the y-intercept here is 4, so we're going to put a dot on the y-axis. And our slope is -3, but we want it in rise over run form, so we're going to make it a fraction, right? This means down 3 to the right 1. So from this point, down 1, 2, 3 to the right 1. We're going to do that until we mostly run off the coordinate plane. Down 1, 2, 3, right 1. 1, 2, 3, right 1. Now we've said it's a dotted line. That's true. So now I'm going to graph my line. I'd like for you to use a straight edge, something that'll make your line not wavy. Use the side of your notebook or piece of paper or student ID or something like that. All right, so we've graphed the line. We call that line here, that's the boundary, right? The line is the boundary for the solutions, okay? Now we have to shade. So looking at your notes, which way does it say we're supposed to shade?
Low, light.
Well, look at your notes.
Shade up.
Shade up, that's right.
Yeah.
So greater than or equal to or greater than means shade up. So we're going to put put your pencil on the line and pull up. Because it's confusing if you just think up. You think, oh, well, that's up. But that's not what we're talking about. We're talking about above that line. So put your pencil on that line and pull up. Now here's one other thing I didn't tell you. So we're going to go back to our notes page. When it's a solid line, any point on that line is part of the solution. So we're indicating by the fact that it's solid that those points are shaded. So let's go back to our notes and add that. And maybe add it, dadnabbit. I don't know if you have room to add it here, but I mean, if it's a solid line, the line is part of the solution. The points on the line is part of the solution. I can't even read that. I don't know how y'all are going to read that. Hold on. So a solid line means all the points on the line are solutions to the inequality. So if it's a solid line, points on the line are solutions to the inequality. Are solutions. We're just going to leave it at that. If it's a dotted line, points on the line are not solutions. So when you graphed on a number line, you had a solid dot and an open dot. An open dot meant that number wasn't part of the solution. But a closed dot meant that it was. Does that sound familiar? You guys remember that? All right. Well, if you'll remember it here, that's all I need you to do right now. So here, if I were to pick a point on this line, like 0, 4, if I plug in 0, 4 here, it would make that inequality a true statement. You guys caught up with me? Okay. So here, we know that any point on that line would make the inequality a true statement, okay? So let's graph number 4 is a special one, right? If it's a y-only line, what do we know about a y-only line? Sam? Very good. A y-only line is hoy, right? So it's going to be a horizontal line through this point, right? I'm not going to do that one for you. Hopefully you can do that one. But let's do, let's not do 6 because we just did one with the same inequality. Let's do one let's do number 3 because number 3 messes everybody up because that's negative. But also I want to do number 3 because it doesn't have a line underneath it, okay? So we're going to do number 3 together. One less problem you have to do for your homework. We're doing it now. This is in slope-intercept form, so I can just start by graphing the line. Remember, the line is the boundary for the solution. Sometimes that boundary is part of the solution. Sometimes that boundary is not part of the solution. If it's a solid line, then it's part of the solution. Is this going to be a solid line or a dotted line? Dotted. So let's go ahead and put the points in, and then we'll draw a dotted line. So the y-intercept is -5. So graphing lines is what we did last unit. So this slope, what is the slope of this line? Very good, -1. And since it's rise over, we want to put in rise over run form. But now I can go down 1 and to the right 1, but now I don't have any other points. What can I do to go up? Good. Move the sign, yes. So 1 divided by negative 1 is the same as negative 1 divided by 1. So now we go up 1 and to the left 1. So we're going to do that. Up 1, left 1. Up 1, left 1. All right, now we're going to draw a dotted line through it. And now this means any points on that dotted line would not make that inequality true. So none of those points on that line are part of the solution. So now which way am I shading this inequality? Up. So remember, put your pencil on your line and pull up, and then you'll have the correct part shaded. So we're going to shade all the way out on our coordinate plane. It's a lot harder to do this if you can't graph a line. The line is the boundary for the solution. So there's an infinite number of solutions. Any point that I pick out here, if I plug the x and y of that ordered pair in here, it'll make it a true statement. Any point that I put from the non-shaded part, not part of the solution, if I plug in the x and y coordinate here, it won't make it a true statement. All right? So far, so good? Tavion, you good? All right, so now let's do one of them that's not in slope-intercept form and remind you how to do that. You only have 2 of those, but we'll do one of them. You said number 10, DePaul?
So, with 9 and 10, they kind of like cut off after like, you make it
the graph got cut off.
Oh, really? I don't think you're going to need that part. No, we can do it that way. It'll be fine, but thank you. I think it's going to work. Let's do, actually, give me 1 second. I've got to get something. Oh, I don't even know if this is over here. This ain't the one. Hold on, I've got to get something going for right after work. Pause for a second. It is not food. It is something the math department is putting on for the rest of the school, so we all had to do our part, and this is my part. But I got to heat it up. I set myself a reminder so I would not forget it, so it'll be ready on time. Okay. All right, guys. I know I interrupted. So let's get back on. You guys are doing a great job. My bad. All right. So let's look at number 10. We have to get, before we graph any line, we want to write it in slope-intercept form. So let's go ahead and do that over here on the side. 5x minus 3y is less than or equal to negative 15. Isolating the y, the first thing we do is get rid of the x term. We either add it or subtract it. If it's negative, we added it. If it's positive, we subtract it. So now we have negative 3 times y is less than or equal to negative 5x minus 15. Now here's something you may not remember. We've got to divide by negative 3 here, right? So when we divide by a negative number, when we're talking about inequalities, does anybody remember what we have to do? Switch what? The inequality. Let's use the right words, but yes, flip the inequality. So now instead of less than or equal to, I do know what you mean, so I'm proud of that, but I need you to practice using the right terminology. Plus 5. Does that make sense to everyone? Now we're going to graph our boundary, which just means graph the line. So we start with the y-intercept at positive 5. And now we're going to use the slope The slope, what's the slope of this line? 5 over 3, 5/3. So this wants us to go up 5 and to the right 3. Can we do that here? No, but we can write an equivalent expression, which -5 divided by -3, right? So down 5 to the left, 1, 2, 3. I'll get it in a second. Down 5 and to the left, 1, 2, 3. Now is that, what'd you say, DePaul? Good, solid line. It's got a line underneath inequality, it's a solid line.